Welcome everybody to the 13th community meetup for the AI and digital data science group. Thank you very much everybody for joining. Today we're going to slightly change the agenda because we have our special guest Akash Murphy. Hopefully I pronounced that correctly. We're going to go straight over to him. I'm just going to introduce, he's the co-founder, CTO of Uprime. Uprime started out as an analytics company and built software solutions in healthcare, branched out into the domain of automatic speech recognition based solutions for doctors, transcriptions needs, which ran profitably for many years. Uprime developed a non-contact health vitals device for which received several grants, prizes. The company has a learning, inference, and networks lab in one of the Indian Institutes of Technology, with the head of the lab being the other co-founder of the company. Akash himself studied electronics and communication engineering for an undergraduate degree and did his master's in statistics. Just doing a master's in statistics, Akash, is impressive enough. So I'd like to hand it over to you, Akash. Do you need to share your screen?
Yes.
Okay.
I think you have to make me.
Mohammed, did you?
Yeah, done. Can you share again? Try again. So.
Yeah, you can see the screen, right? Yeah. Hello, everyone.
Yes.
We'll just get to the talk. This introduction about myself has already been given. I'll keep it. I'll keep the talks as a mixture of people who are slightly advanced at the same time, so people who are beginners. So I'll keep it open to both the people. And if you have any questions along the way, you can stop me and ask the questions. You don't have to wait until the very end to ask questions, so that it becomes contextual and I also have context to answer questions. So basic outline is we'll just understand the general concept of ML for a slide or two that gives you some understanding. So I'll just minimize this. So what's happening in ML is this might be a little technical, but all you have to understand is there is a general law of the world that needs to be captured in some meaningful model that we build. Okay, I'll repeat. There's a general law of the world that gives you a distribution that needs to be captured in the model. Okay, that's what we're doing in all ML theory. So even if you don't read any of it, you can understand this idea that the general law of the world has a distribution whose first moment is, let's say, the first expectation. And that is essentially minimized, and that value is eventually arrived at. Also, all of ML is a transition between data to labels. Okay, so just to set some let's say human language context to it, everything is a mapping between X's and Y's. Y's are the labels, X's are the data. Another way to think about this is in the supervised context, Y's are the dependent variable, X's are the independent variables. And as I stated previously, they all follow some distribution. We assume that they follow some distribution that we have to infer and match using our technique. So I just want to delve into this because all of ML, all of AI is essentially some version of this slide. So this is the general law that we are trying to understand. And the observer, let's say you can put it in human universe context as well, or let's say universe and observer context. We are trying to sample data and get an understanding from that sample so that so the second equation is closer to the first equation. If we do that, I think we are running a very successful model. Okay, that's the main goal, is essentially trying to compare the let's say the universal law to our sampled version of the law. And the idea of sampling is to construct a universal set which captures the entire population, which is the set of the. So I mean after that I won't delve much into details on the other aspects, but on this slide, if you understand this, the general intuition of machine learning is sort of clear. Again, I can describe this in greater detail. So there will always be some version of W transform X in all models, and X is the vector that you're trying to transform, and on the left hand side is the Y, which is the label. Now, coming on in terms of differences, as I previously stated, all ML AI techniques is a transition between one kind of data to another, one vector to another. So this transition needs to be understood. If you don't have labels, then it will be unsupervised learning. So clustering, dimension reduction, these are some of the techniques. Now, how does this slightly differ from the generative model? Generative model, the end goal is not a number. The end goal is usually language, audio, video. If the end goal is language, audio, video in the current, let's say, in the current generation of AI models, those are called generative, meaning you're generating something from that data. It's not just an output. It's not a classifier. You're not giving a score or a threshold. So those kinds of models are generative AI. Now we'll directly get into, I'll cover 4 of these models in slightly greater detail. One of the first models, and this is also true chronologically. Autoencoders, where some of the first ones have something in chat, right? How do you decide what labels are important? How do you decide what labels? So you decide based on the problem statement, right? So if I have to, I can answer this question. It's not that big a deal. For example, if you take a classic regression problem, the Y is the baby's weight and X is the mother's weight. We know that through prior understanding of the problem. Okay, this is all like you use some human knowledge. You use human knowledge that you acquired, and over a period of time, for the last 100, 200 years, we've figured out baby's weight is always dependent on mother's weight, and that's the most dominant factor. And that's what informs you to build, take labels Y as baby's weight. So answering your question, prior knowledge of any domain tells you how to label. If I have understood, answer that question. So properly. So in terms of autoencoders, you're trying to reconstruct an image for that pattern, right? And you will put it through a transformer, and you will construct what is called a latent label. What is the connecting tissue with all the techniques that I'll cover today? There will always be a latent variable Z. Okay, so X is the data. I'll keep the notation constant throughout. So X is the data, and you want to get X back by transforming it to some latent variable. Think of it as political affiliation as Z. You cannot make out somebody's political affiliation. It's not a variable that you can measure. So you'll collect sample that you can measure. From these samples or features, you can infer what Z can be. So you can figure out if somebody leans left or leans right, and then based on that, you can reconstruct what X is. So apparently, this has use cases in terms of language or audio or video. So this is the general setup of generative AI. So popular examples, talk will be a lot more technical, but initially I just want to give that some context. ImageGen, DALL-E, Stable Diffusion, these are all examples. ImageGen generates, pictures from text. So text prompt leading to a picture. Now, again, this is a problem setup. Every ML problem has a setup or what we call problem statement. And this is how you essentially set things up. So there are X's and there are contexts here. The difference between, let's say, slide, which is different from the traditional ML models is C has context. So context is the, text that you've given. Now, given this context, you have some data. How do you generate, what can you infer from that is what we're trying to understand. Again, latent variables, I just want to reiterate this definition so that it becomes clear. It's not a tangible variable. What I mean by that is political affiliation or temperament of a human being is not something that can directly be inferred. So you can infer it with some context. That's what latent variables are. And you're trying to model latent variables in all generative AI techniques without exception. So we have to learn the parameter theta using some data t, and and you do that by. And again, another thing that I want to specify, which I specified in the first slide, is that whenever you have natural law of the world that you want to infer, the natural law of the world, follows some distribution. Okay, and you want to learn the PDF of that distribution, probability density function of that distribution. And every one of these models has some assumptions, right? You assume that this focus here is continuous model. So that you shouldn't ask why is this not a discrete object. We are in the continuous domain now. Context can be included later with this. So these are the 4 techniques that I previously stated that I'll be dealing with. If you have any questions on these, happy to take. So probabilistically, what we're doing, we have some prior, let's say, PZ, and we want to calculate the conditional probability that P of X given some Z, right? Given somebody's belief or given somebody's, if someone has to tell me if there are any questions, I won't monitor the chat. So please interfere and ask me the question. So we are trying to estimate the conditional probability Px given Z. This one. So we use data analysis to identify the weight and importance of the label based on the result of expected output. So you use data. Now I wouldn't say data analysis. I would say prior understanding of the field. You can use data analysis, but that kind of category of that sequence of events would essentially be unsupervised learning. What you would ideally do is consult a doctor, consult a pediatrician, and ask him what is the outcome variable. Okay, outcome variable is the dependent variable, that the variable for which you design an experiment, and the outcome variable is you infer the outcome variable, or you just ask the outcome variable from an expert. You ask a pediatrician, what do you think in your best estimation the baby's weight is dependent on, or do you think it's worth studying baby's weight? And he states the problem. Okay, think of it in that way. In the real world, there are lots of problems, and you solve those problems using these techniques. Don't imagine that this is some esoteric field wherein everything has to be done on data. This is just modeling the real world as much as possible. So you ask the expert to, not input, but to understand what problem to study. And if you ask the pediatrician what problem to study, he will say, I want to predict the baby's weight before the baby gets born. So given that, that's what we're going to do. Hope I answered the question. So we will feed these latent variables into the decoder, and we are individually trying to get the parameters here. Again, I'll describe what a parameter is. So every distribution has, if we do point estimation, we get mean and variance. Mean is the first moment, the variance is the second moment. So any data set, if it follows, we assume that it follows some distribution. At the end of, let's say, statistical procedure, we'll get some parameters, and usually it will be mean and variance. And variance can be extracted from what is called the covariance matrix. Covariance matrix properties are used to infer a lot of these techniques. So in this particular case, it is just the diagonal elements of the covariance matrix, and covariance matrix is always a square matrix, because you're trying to it's always a square matrix where the diagonal elements are variances and the off-diagonal elements are correlations between the x's and y's. So imagine there are 5 x's and 5 y's. The correlation between that is what you're trying to infer from off-diagonal elements. And you want to be able to train X to eventually get this conditional probability, meaning like you have all these mean. Each mean is, imagine X to be a vector, and you will have corresponding means, mu x1 given z. Z remains constant, but you infer all of it. And your job is to use that and feed that into the network. Okay. So again, while in all ML cases, you're trying to marginalize with respect to some, variable. Okay. You're marginalizing. Marginalizing means this technique. Okay. So essentially, you're trying to calculate the probability density function. So probability density function calculation is sometimes intractable. Intractable is a word that we use to essentially say it's a hard problem to solve. Whenever it's a hard problem to solve, we use some techniques to solve this problem, meaning that evaluation of this RHS is harder. Okay. If there are any questions in this, I will. Thanks. Okay. So all ML problems are estimating.
Oh, hi. Sorry to interrupt.
Sure.
Yeah, it's okay to, sorry, I joined a bit late. It's okay to go back to some earlier slide. Just want to see some definition. Like, I don't remember. Is it slide number 2 or 3? If that's okay with you.
Yeah, sure. Yeah.
Yeah, I think just go back to the slide number 2 or 3. Can't remember exactly. Yeah. Okay. Okay. Right. Oh, sorry. Yeah, I think it's here. Okay. When you say God, what does it mean? You mean like the ground
Can you repeat that word again?
You mentioned about God, like God, and does it mean this is the ground truth, or I think in
Did you say
your slide, God, God.
God.
It's the earlier slide. It's the earlier slide that you explained.
Oh, okay. This is
some
me.
earlier slide.
Okay, don't take this seriously. I'm just trying to say there's a natural law of the world. I'm not trying to model God or anything. I'm just saying. I'm just being funny here. Don't take it any seriously.
Oh, okay, understood. Okay, and this slide is okay, and then this one.
But if you have any technical question, these are just meant. This is a serious talk, right? So I just added some humor saying that we're trying to model the. This is a scientist way of saying.
Oh, that's okay. That's okay. Understood. Yeah, fine.
But I think you have any questions on the right hand side.
Yeah, minimum of the expectation of which is the loss function, right? The L, right? Okay, understood. Okay, that's fine. Yeah.
Oh, you didn't think that? I'm actually trying to model God. That's not the point. So,
okay, understood.
The PDF is essentially intractable. So we have to use some variational approximation technique to solve this intractable PDF problem. So we do that by adding some auxiliary variables. Why do we do that? When we do that, we make the expression convex. The idea is if you have something as convex, you get something called a closed form solution, wherein we can evaluate this by adding this auxiliary variable qi. Essentially, you're making this problem into a convex problem. If you have convex problem, we can evaluate this slightly quicker. So that is the broader idea. So if I can get into details as to where variational approximation, all variational approximation techniques are I wouldn't say all of them. I think most of them have got to do with making the problem into an unknown problem into a known problem, or making, in this particular context, the entire domain into a convex set. If it is convex, we can evaluate quickly. But I can get back into details as to how we have done this, but if the need be. It is a lot like expectation maximization algorithm, but not quite in the sense like we don't assume a lot of the properties on the decoder here. We're not trying to estimate the parameters. We hope that the decoder takes the parameters into account and eventually gives the output. So here, the broader idea in terms of at least intuition is we're trying to find KL distance. KL distance is trying to find out the distance between the prior and the conditional probability. And it's again, this is this is not like entropy regularization and optimization. So the techniques, adding the auxiliary variable, making it convex, and converting that into a closed form solution is essentially estimating KL distance. You can look up Kullberg, Liebberg distance online. We can figure it. And another important technique for autoencoders, and reason I'm dealing all of this in autoencoder is it's the precursor to all the models that exist chronologically. So we train the let's say encoder separately, and we train, let's say, another version of the network separately. So that's one of the let's say benefits of doing variational autoencoders. So we and how to sample QFI. This is essentially so there are two parameters here. There is a parameter F that we introduced. I think there's some notation issue, but I think I can get past that. But in terms of broader idea, what are we doing? We're sampling from a parameterless distribution, and we are offloading all this onto the encoder, hoping that the encoder does the estimation. Encoder does the point estimation, and it gives us the output is what we're trying to get to. So eventually, the encoder outputs the means and variances, the first moment and second moment, from using this auxiliary variable. That's the idea. Again, I'll keep it to the bare minimum, and eventually the closed form solution looks something like this. And wait a second. Yeah. So this is the eventual output. So the advantage of doing this is whatever latent variable that you have, you train them parallelly. That's one of the advantages of doing all this, and you don't assume anything on the parameters even when you feed them. Okay, and this technique that I told you, right? Eventually, we are calculating some version of conditional probability of X given some latent variable. I just want you to not forget the eventual goal. There's another question. Can you share the presentation since it's not enough time to cover everything? Okay, I'll see what I can do about it. What to do if it is intractable? What to do when it is intractable? Okay, so that is what we suggested. So any problem. Okay, what is the broader principle here? The broader principle is whenever there is an unknown entity, unknown quantity, you convert that into known quantity by modifying it in some meaningful way. Okay, that's what we do whenever something becomes interactive. We convert that to the closest known quantity, and that is what they're trying to do. This is a classic, technique in math as well as optimization and ML as well, wherein you convert that into something that is known, and then and then you go ahead and try to solve it and eventually get the solution. So what are we trying to get at is we're training these encoder and decoders separately, and then we are feeding it eventually to get the parameters. From the parameters, we are trying to estimate the maximum likelihood for probability density function. So that is broadly it. So you initialize theta and phi networks randomly, and then you run a batch. You run a small batch of X's. You don't take all the data, and then you try to estimate. And then you add some prior noise as well. Okay. This is Gaussian noise. I didn't mention this, but assume whenever you encounter noise in this slide, assume that it's Gaussian noise. That means it's properly studied, which has whose parameters are easily estimatable. Again, I'm stating the same thing again here. Okay, I'll just state that the limitation of this is it's sometimes hard to train phi and theta jointly. Yeah, that's one of the things that we will be looking at other techniques as to how this can be overcome. So I'll just take the other technique. So now I think everything is related. So please keep the notations that you looked at in your mind. We are all trying to use, trying to use XS switcher samples. We're trying to model Z, and we are trying to output the XS back. Okay. Now normalizing flows. This is again. How is this different? This is essentially a bijection. Bijection would mean like if there is a vector and you transform that vector into some output which is y, you can go both ways. Okay. And can anyone tell me this is like a question to do bijection as a general mathematical operation? What is the necessary condition? Can anyone take a shot? I'll just give 5 seconds if nobody answers this answer. Okay, so to do general bijection, the transformation, the matrix that transforms x to y has to have an inverse. If it has inverse, then I think the bijection is possible. Now, so again, going back to x's and y's, you have vector x and vector y, and let's say x to x hat. Now, if you can go back and forth, if you're able to have a transformation which has very specific properties, which has an inverse, that is the broader story here. And here also, based on the previous technique, we allow some change of variables to compute Pz. Pz is again some version of probability density function only. Here we use, because inverse is possible, the inverse of the transformation is possible, we can calculate something called a Jacobian. Again, Jacobians are partial derivative of some function that we're trying to estimate with respect to all individual coordinates. This is the same thing that we do in gradients as well. In case you're ever taking a gradient descent, you have some estimate in it's ft minus eta. Some function exists outside of that. That function is essentially gradient, meaning like you have a unit ball, and your idea is to do partial derivative of x coordinate, y coordinate, and z coordinate, and add them all up, so that the neutral direction that you get, that is the direction that you have to traverse. That's the intuition of gradient descent. In case maybe we're trying to do some version of this here as well. So that intuition has to be very clear. Why does gradient descent work? And it's not a new technique. It's been 150, 200 years since gradient descent was invented. And why does it work even now? Because it's almost non-intuitive to the human mind. Whenever the human mind decides, human mind is trying to do a greedy version of the algorithm. Greedy version would be, so I'll just give you an intuition. So even if you don't take up all the details of the talk, just have an intuition as to how these techniques work. So you're trying to get, you have a unit ball, and unit ball has, let's say, 3 coordinates, and you're trying to find partial derivative in each one of the coordinates, and you want to add them up. That is the definition of gradient. And you're able to do that at every point. So you're able to improve the direction, and you eventually go to the right direction. That is the, intuition as to why gradient descent, which is a very 150-year-old stuff, 200-year-old stuff, still works. So you're trying to estimate, you're trying to do the same thing here. You're trying to do some version of technique here as well. You use a couple of techniques which are essentially compositionality and autoregressiveness. Compositionality is essentially able to add up a bunch of random variables which all follow normal distribution. I don't know if I've written the definition here. Yeah, I haven't. Okay. Yeah. So you're able to, if all of them follow some version of let's say normal distribution, you're able to separate and add them and have functions that can be defined. If these two properties can be found, if it exists and if it is allowed, it gives you a nice transformation structure in the matrix. The transformation structure is the fact that it's a lower triangular matrix. So basic matrix theory, that if you have lower triangular matrix, when you find the determinant, it's always the product of the diagonals. Okay, this is what you have to remember. So think of a matrix. Okay, all the elements on top of the diagonal are all 0. All the elements at the bottom of the diagonal exist, which are non-zero. If such matrix transformation does occur, then the determinant is always just the product of the diagonals. Because how do you estimate a determinant? You can also, another quiz question for all of you: what is the notion of it? What do you mean by determinant? Whenever we calculate the determinant of a matrix, what does determinant mean? That's a quiz question for you. Someone who can answer that will get a special mail from me. But somebody has answered this. It means area. No, I won't say. I won't go straight up as area. There's something else. But yeah, you're in the right path. You're in the right
Scalar
path.
value, something like scalar value.
So I think it's like calculating the volume. Okay, calculating the volume. So if you look at parallelogram, and there's something called parallel pipe, and you calculate the volume of the parallel pipe. When the formula of the parallel pipe was invented, I think that looks a lot like the determinant. So whenever we calculate determinant, we're calculating volume. So you're trying to estimate volume, and we make the volume structure and at least the transformation in such a way that it transforms to something like this, product of values. So essentially, you are doing some matrix technique to get transformations that you want. So these kinds of, I'll just explain what autoregressive means. You feed X, which is the input data, you get Y. And you feed Y back into the second transformation, and you get Y2. And again, you feed both X3, new data, so X2, X3, and then the transformed version, you feed it back into the network. If this is true for all n's, that is autoregressive transformation. So in this normalizing flow, autoregressive compositionality and autoregressive transformations have to be true. So even though it's a beautiful way to solve the problem with this is it solves a very narrow class of problems, wherein invertible transformation limits the capacity. That's what I'm trying to say. Invertible transformation limits the capacity of the model to generate high complex dimensional objects. So when we hear high dimensional objects, you think of it as language, image, audio, and also it's too slow. Right? Anything which is too simple and it gives you a nice form also means it's very hard to compute. Okay, now we get to the GANs. And as you pointed out, that the previous technique is slightly slower. This is essentially GANs are slightly. I haven't written the diagram here. Okay, so think of it this way. There is I'll explain it manually. I think we should have had the diagram somewhere. Okay, I think I've missed that slide. So GANs, I'll just explain. There is a generator network. There is a discriminator network. Okay, you take the original data, you put that into the discriminator. Discriminator is a classifier. You all would know what a classifier is. It will give you a threshold above which you can classify class membership of one category with another category. Okay, there is a discriminator, and the generator takes noise data and it tries to fool the discriminator into thinking that it is true. Okay, so I'll repeat that again. So you take the regular data, X's, and you put that in discriminator. It classifies whether the X is true or false, whatever that classification may be. Now, what the generator does is it takes noise data, Gaussian noise, takes noise data, it then feeds it to the discriminator. Generator feeds the output into discriminator and tries to trick the discriminator into thinking this is true, which is it isn't, but it tries to do it. And this battle between the generator network and discriminator network, who have an adversarial relationship, right? It's like the board of the company with the shareholders, board of the company and the executive team. Executive team delivers the operations of the company, but the board protects the interests of the shareholder. There's an adversarial relationship, and because of that adversarial relationship, they're always at loggerheads. So you're essentially trying to capture that relationship here. Again, this expression looks complicated, but it's not complicated at all. So there is a discriminator function, as I previously stated. You're taking expectation of the log of discriminator, and you want to take the 1 minus discriminator, which takes the input of the generator. As I previously stated, the generator network feeds the output back to discriminator, which is essentially latent variable. This is the actual sample. These are the latent variables which are generated by feeding Gaussian noise into the generator, and it tries to trick the discriminator into thinking this is true. Okay, and this battle between, let's say, the networks is essentially adversarial, generalized adversarial networks. And you do ascend, and you do gradient ascend on the discriminator, and you do gradient descent on the generator, and you combine that, and this is the function that we are essentially optimizing for. So I won't go. I think I should have had the diagram. Apologies, I don't have the diagram, but I think I've given you a general sense as to how GANs work. You can Google this. This was a huge technique in the 2019 to 2020 era. I mean, it seems like very ancient, but very recent. In that time, GANs were everywhere. There wasn't a single field which didn't use GANs. Again, GANs, they also have limitations. GANs are sensitive to noise in the data. Small perturbations in training can have significant changes. Instability, whenever you have words like hyperparameter is some weight adjustment that you do to ensure that the model works right. And oscillation, these are all stability problems of a control system. Yeah, obviously. It provides matrix information about matrix. Is that now invertible or singular? I want to go see invertible is different than singular, but I mean, this person can probably come and ask the question directly, but provides property information. Oh, about the matrix, you mean? Oh, okay. I think you're talking about determinant. I think. Okay.
Yeah, you asked the question, right? What is determinant?
Yeah. Okay. Of course, it's a property information about the matrix, but what does matrix mean to the real world? How can you explain this to let's say, your parents? If your parents don't understand mathematics, how will you explain this? You cannot say property of the matrix, right? They'll say, what is matrix? Right? So it essentially gives you volume. Volume is what I'm looking at. And if you look at parallel pipe volume, the formula remains the same. So instability, again, the problems here in the GAN is it's too unstable, and doing that is again here I have tried to generate GAN in some meaningful way using one of these stable diffusion models, seeing how it works. But I'll just get to the last one. This we actually have few more slides, but I haven't added it, wherein we have done some interesting work on this, which is taking into effect the limitations of denoising diffusion models. The basic idea of denoising diffusion models, if you don't understand, let's say the math behind it, is you take any image, you add some Gaussian noise to it, and you, let's say you have a 10-step process to add noise. So the image that you see is, let's say, a slightly clearer image, and every step of the process, you add some noise to it, and it becomes noisy, right? And let's suppose there are 10 steps. You have access to all 10 steps. You figure out how to go from step 1 to step 5 to step 10. And if you were able to go back and forth across these, let's say, you're essentially noising it and denoising it. So there are two processes in this model. I can go back to this image again if need be. But essentially, there is a forward process which induces random noise to a very proper image. And then you have a series of steps until it becomes pure noise. Everything is complete noise. And because you know the forward process and you know the intermediate steps, you're able to reverse the process as well by denoising it. If you're able to do both these steps as part of the training, then I think DDMs work properly. Okay, that's the general intuition. Again, here also you do the same thing. You extract, let's say, some Q, which is, let's say, conditional condition probability of xt given xt plus 1. This is like, let's say, if you're going to the forward process. And you do that by estimating. This is always true across all ML and all statistics. You do all the operations, assuming there's a mean, and then you have some variance. And if it is standard normal, that's the difference between standard normal and just pure Gaussian. It's like you assume that the mean is 0 and it's centered, it's not separate. The reverse process is the same. Chatting. There's difficulty to understand mathematics symbols mentioned in your PPT. Which course do I need to take to be able to understand this easily? Is it discrete math? I think it's a panoply, meaning it's a panoply of math courses. I think that the mathematics that is required as a mandatory thing, if you're, let's say, you haven't studied all this in college, would be linear algebra, probability theory, some version of optimization. If you do all three, I think most of ML theory is just these three. I would say linear algebra is the dominant one, probability theory, because every ML algorithm is calculating probability density function in some meaningful way. So you should have a general notion as to what a PDF is and what a normal distribution is. So I'll ask another question. If you don't know what normal distribution is, right? Why is it called normal? You can answer that. Why is that distribution normal and other distributions? Or like, why do you see normal distribution all the time? What is the expression of normal distribution? And why does it have this bell curve? So if any of you have any questions on that, I mean, or intuitions as to why it is the way it is, or even the expression for that matter, 1 upon sigma root 2 pi x e to the power of, you have minus x minus mu divided by sigma square. Why do you have that expression? And I can break that down properly if the need be. But if you understand that, you'll basically understand why it is normal and why we use these techniques. But I think you have to go slow. I think statistics is also important, but probability theory covers most of the statistics. The reason I went with this mode as opposed to doing a marketing version of this is this adds more grounding, right? A lot of the other people on the internet also teach you models. It's like a black box, but you don't know what is happening inside. So I wanted to, that was the motive of the talk. Very like you get an intuition as to what is happening underneath the model, so that it's not this is the expression. Thanks, Arshad. So everyone, if you focus on this, you have to be able to tell me why each one of these expressions are the way they are. And e to the power of minus x square is the broader thing here. E to the power of minus x square gives you a okay. The notion that it is minus mu means it is away from the standard normal. If it is normal distribution follows 0 and 1, then you don't have mu here. Okay, mu ensures that the normal distribution has moved away. Okay, and the reason you have 2 pi, I mean, if someone can tell me that, I'll be very happy. But I can explain that as well. So essentially, you have normal distribution in 3-dimensional space. When you cut the normal distribution, the area underlying that is root 2 pi. Okay, and if you take any point on normal distribution curve, the distance between that point to the center of the cut is essentially, I think that was some version of root 2 pi. That distance is root 2 pi, or some version of root 2 pi. That's why root 2 pi is here. So let me explain that again. So there is normal distribution. You cut the normal distribution right at the beginning, right at the center. Then in any point that you take on the normal distribution, that point to the central point where you cut the normal distribution, that essentially that distance is some version of root 2 pi. Okay? And root 2 pi has got to do with the area under the curve. So whenever you have denominator anywhere in math, it's some version of area under the curve. Any formula anywhere in math, if you have denominators with some big expressions, it's basically, I won't say this is always true, but always look out for area under the curve. Okay? It's calculating area under the curve, at least in this sense. Okay, so at least I mean, this is I think, yeah. So again, training every ML model has some eventual expression that is trying to minimize an expected value. Every time you see E, you're trying to find an expected value. Expected value is trying to find the first moment. First moment is the parameter mean. Okay. Second moment is variance. Okay. Okay, I haven't added much to it, but I think there were further slides that I removed because these are papers that we haven't published yet, so I didn't want to put that here. So I think broadly the idea of denoising diffusion models is you add some noise and you transform it. Every time you transform it, you get a subsequent intermediate step. You take the intermediate step and you convert the entire thing into a noise, and then you convert the whole noisy image back to a proper image. Because intermediate steps, you can go from any intermediate step to any other intermediate step. What I mean is, if you're in step 3, you can go to step 7. If you are in step 9, you can go to step 4. That ability to do that ensures that you can create images. So another intuition that I want to give you is all these new images that you're getting, all the videos that you see from generative AI, what they're taking is they're taking frames. They're taking each frame and they're sequencing it any which way they see fit. Okay. So that is broadly what is happening. Now they're changing some image and they're making you pronounce things in a different manner so that they can come up with their own videos. So that is what is happening. Essentially, you're playing with the frames and you're sequencing the frames in a manner in which it produces the pronunciation. By the way, there are only about 44 phonemes in the world. Phonemes are like sounds that you make, like the way there are 26 alphabets. There are 44 phonemes. From these 44 phonemes, you can generate any sound in any language. Right? It seems almost hard to believe, but 44 phonemes are enough to generate any sound in any language. That ensures they can each pixel. I don't know what pixel part, but I think frame is. This is the thing that is powering most of ImageGen. ImageGen is some version of denoising diffusion models. So yeah, I don't know what pixel. It's hard to do, and it's also see anything you have to always say if somebody has done something. You have to be skeptical and say like, is it computationally viable to do this? And that's a question that you guys have to ask. At this point, I think I have covered all these, let's say, 4 techniques. If you have any questions on any of the 4, I would like to take. I think I've pretty much covered the whole thing. But I would get into details and explain as to what is a convex set, why convex sets are solvable, why optimization is used, and these questions. If you have, I can give you general intuition as to one-liners as to how these things work. But if you have no further questions, do you guys have any questions?
So I think yes, Akash. So there are some questions I know, but you are
Yeah.
you are.
No, I think I can take these questions. So scale distance is essentially trying to find out there. You have a notion of distribution, and you have a generalized notion, as I previously stated in plain English language. You have a generalized notion of a distribution which captures the law of the nature, right? And you have your own estimate of that distribution. The difference between your sampled estimate of the distribution with the notion of the generalized distribution, that difference between that is the scale distance. Kullberg-Leinberg, I don't know how to pronounce that. Kullberg-Leinberg distance, scale distance. So it's essentially finding out how far you are from the idealized distribution. Another way to say this is, I think one of my slides covered this. Yeah, what is the use of Jacobian? Jacobians essentially gives you part. So you're essentially doing, whatever gradient does, right? So you must have heard about gradient descent. Gradient descent is you have an initial point, and at every point you want to calculate. You have a unit ball. Unit ball has three directions because it has three axes and three dimensions. You want to find out partial derivative with respect to each axis, and you have to add them. When you add them, you get the gradient value, and you update that as part of your weight at each step, so that you get a general direction as to where to head, and that eventually converges to the optimum value or the global minimum. That's the use of Jacobian. And here in this case, we're doing it to find probability density function, which is essentially doing some version of gradient descent for you guys to give you to get an intuition. Yeah.
Okay, can I ask a question?
Sure.
If we take a step back from all this, because
Yeah.
I'm more on the business side of it and
Yeah.
the benefit, where's this technology going? What's it been currently used for now? Where do you see its applications will be in the next 5-10 years? What sort of benefits is it going to bring society, businesses, etc., etc.?
This is a very good question, and I think you should pay attention to this question more than any other question. I think it will change societies from a very different point of view than what everybody else is assuming. I think it will change from the entertainment, and it will change every other field afterwards. The first industry which will be hit by this will probably, I won't say significantly, it will increase productivity in the short run. In the intermediate run, the firms will have better bargaining power. As a result, wages will not grow. So I'll give you another historical reference from 1750 to 1840 during the first industrial revolution. The wages didn't go up at all for 90 years. The wages went up from 1840 onwards. So from 1750 to 1840, the firms had all the bargaining power because they had access to technology that ensured that they're driving their efficiency really quickly. The workers wouldn't have a lot of power. So I would say in every industry, this will increase productivity. I think media is the biggest industry that will, at least the current state of the technology, media is the biggest industry because all this is creative work. And I think it will improve aspects of media, but it will also, let's say, you cannot be the 10th best actor in the city. The 10th best actor in the city will have no job, which is also true even now. But I think it will just accelerate that even further. For example, if Tom Cruise will be making movies another 20 years because his face can be used to make new movies, and he won't even be alive, and we'd still be using his face as. I think that's a very realistic possibility.
Yeah, I can imagine.
I think you should. Okay, let me. Patrick, you had something.
Sorry, no, go on, please.
So, how to save your job in this era? I think become vital to a process where I don't think general automation is a scary thing. If you're an executive, if you run the firm, you're in a very advantageous position. So if you want to start companies and somehow come to the other end of the other end of the bargaining table, this is the best way to do it. But if you are, let's say, holding on to a job, I think it will be harder. This also means disruption is faster. If the disruption is faster, that also means conglomerates as a concept will be an ancient history. You might have also looked at this point. Conglomerates only exist in non-developed countries. And this has nothing to do with ML. That's probably because it's easier to take the tools and you can do horizontal expansion in different industries. So I think conglomerates will have a lot of power, at least in the short run. But in the long run, smaller companies can disrupt conglomerates much faster. I think there's a question here. Now there are many methods to fine tune, especially with You can just come online and answer ask this question. RL, I don't know what RLHF is. Oh, this is some version of prompt engineering. Is that prompt engineering? Will that add risk to the behavior that we tuned it in a way that it will lose some of its accuracy? Okay. So I think this is, if I understand it right, I think this is some version of prompt engineering. How does it affect, if that's the question? See, I think prompt engineering is, or like say, whatever you guys say, it's not, even if you're doing all that, the token size right now is about 3,000 words in ChatGPT kind of models. You can increase that. So what you're doing is, at each point, you're trying to find out the next sequence. You're trying to find out, let's say, I'll give you even an understanding of how prediction happens, right? You take the letter C, that's the prior, and in order to predict the sequence after letter C, you look for A, B, C until Z. You try to find out the probability density function of A to Z, and you see which is the highest. The highest is A. A has the higher probability after C. So CA is the sequence. Now, if CA is the sequence, what is the probability density function with respect to each one of the 26 letters? T has the highest probability. So you put CAT becomes a word. After that, the next highest letter is an empty space. That has the highest probability because CAT is a proper word that people use all the time. So that is what is happening in all these models. You're trying to calculate probability density function at each step. Given the reason I mentioned that for this question is, as and when you increase the token size, it has to have an existing sequence that it has to use to predict that consumes a lot of memory, right? So even though token size improves, that means that somebody's spending a lot of energy behind the scenes to make it available to you. So I would say, prompt engineer, whatever prompts you give does affect the state of the model because it changes the sequence. Now, if you put C and if you put B after that, there's no letter. You cannot come to the answer CAT. So that's what I'm trying to say here. So I would say, obviously, it will lose some accuracy. Right? Accuracy is whatever that exists in the real world. So obviously, it will lose accuracy. Answering your question. I can take a couple more. You have any other questions?
Yeah, Akash. Yes. If
Yeah.
the questions are like mainly for the people who are here, they were asking, right?
Yeah.
That I'm sure you have talked a lot of things and you covered very insightful stuffs. But now, for people who want to make a career in this space, right? What are the things you are recommending? You told that, maths. You mentioned few things that are there, but other than that, right? The program.
I think. Go finish your question.
Yeah, just this advice to the people who are actually maybe starting their career in AI and data science. What would you recommend? Because there are so many things are changing, right? Why I'm asking you this because many people ask me this question: what to focus on? I always tell them to start learning the basics, right? The ones that you mentioned, the PDFs, the
probability theory, linear algebra, some version of optimization.
Yes, and
so I think finish your thought.
Yes, this is the thing. Yes, so I just want to reiterate what are your thoughts and to advise because so many things are coming. Should a person keep switching or focus first, making the foundation strong, the basics strong, and then build over it later?
Yeah. So my suggestion to that is customizable and tailorable to each person's needs. Right. First, figure out who you are. Right. The advice is different for different people, and not everyone has to be fundamentally strong on everything. It depends on who the person is. If the person comes from a media background, so that's a prior, right? You think of it as a modeling problem. People come with inherent abilities and biases and capabilities. So you build your career on top of what you already are good at, right? Don't try to compete with something which somebody has spent, even though all these techniques have come out, people have spent 10 years on this and eventually some model comes out. So don't compete with some researcher who's been doing this for 10 years. I think your niche ought to be figure out in your career where you are and what experience that you have uniquely. That is the prior of your life's problem. Given that prior, what do you want to add that accentuates your ability to a point where you can be a unique contributor and tell a unique story about yourself to any company which is willing to hire you, be it machine learning or otherwise. So I would say look for business intelligence tools. So That's the theory. But what does it translate to in terms of actionables? Look for business intelligence roles. So if you think of it as three layers, you have analytics, you have data science, and you have ML. ML is the, let's say, the hardcore stuff, which has all this math. And most of it is, ML engineer is you're taking a model which exists, you test it out by adding some data, and you fiddle with the data model. Okay. ML scientist is somebody who comes up with these new papers. You have a nice mathematical technique, you have a nice matrix property, how to make the matrix in lower triangular, how to make the matrix lower triangular in a manner in which the product of diagonals gives you the determinant. Now that is ML scientist. Then you have ML engineers who take the models, fiddle with it, ensure that it works for the given problem. That's ML engineer. One level lighter version of it is data scientist, wherein you look at data, come up with business insights to solve a business problem which minimizes cost and increases revenue. So this can be very intense to something much lighter depending on which industry you're in. Data science. So another even lighter version of data science is like business analytics, business intelligence, wherein you're looking at consumer insights, consumer spending behavior, marginal propensity to consume in any given sector, using that as the basis to figure out what kind of products to come up with. So these are all sectors which are open, which have existed even before. It's just that every company will have a BI person, business intelligence person, data science person, ML person at some level. Just in the same way, every company is a tech company now. Now every company will be an AI company in some meaningful way. Data will be like the forefront. And I think it's a useful, my suggestion is figure out who you are as a person. What are your strengths and build around that is what I would say.
And one more last question is what are your thoughts on, because I know we have also discussed, what are your thoughts on ChatGPT as a business model? Means
When you use ChatGPT as a business.
No, what I mean is what is your thought about this tool? Because many, as a statistical person, because many people tell that it is just stealing data. It is just who is the owner of the output of ChatGPT, who is the owner of the output of the images, who holds the IP right, because at the end of the day, they're training on data that was created by someone else. So what are your thoughts as a statistician? I just wanted to know.
Yeah, so I would quote Mario Puzo, who wrote The Godfather, who's in that, and he says, behind every fortune there is crime, right? So ChatGPT is no different. They're stealing data from anybody and everybody and building their model. So behind every fortune, there is some version of ownership stealing or, So I would say, I think they're stealing the copyrights of lots of companies. And these companies are weak. It's not that their companies want this to be stolen. It's just that they're weak in technology. And these guys know how to scrape data and use data in efficient ways and beat the laws because the laws haven't been established yet. We don't know the boundaries of what is a public license. If somebody issues a public license on software or music or their own face as an image, nobody has disputed that in courts of law anywhere in the world. So what these technology companies do is, I think they're not malevolent. They are trying to solve some, efficient problem. But I think they step across the chasm of what is considered the norm, and they take advantage of it. I think my opinion is it's a moot point. I don't have the answer. It's something interesting, creating conversation ready for AI. I think you should get a team. You should get somebody who's a consultant. Get Arshad as a consultant. He'll explain to you how to create a data science team, or at least get them on an hourly basis, let's say 10 hours per week, and talk to them as to how to build the data strategy, and get a business person as well. I think somebody like Arshad or anyone he trains would be a useful skill set. So get somebody on an hourly basis to begin with, month on month, and then eventually transition into a full-time person. That's pretty much it from my side. Anything you can all see if anyone wants to reach out. I think, but I think you can reach out to Arshad, and I'll figure out a way to give the PPT in a day or two. But by Sunday I can give.
Yeah, it's very interesting. Thanks a lot. Patrick, yes, over to you. Sorry.
Oh no, I just say thanks so much, Akash, for your time. It's really I appreciate you're very busy, and it's fantastic to have a person of your level and knowledge on the group. So we really appreciate it. So thank you so much.
Thanks, Patrick. Thanks, Arshad.
Thank you. We'll have more sessions, Akash. I know you're busy once you're a little bit settled.
Sure. Apologies for I'll be there. Just I won't be there on video.
Sure. That's fine, Akash. Yeah, we are now just going to give a weekly update, and thanks for your time. Best of luck for your talk in the Indian Day. And have a great day. Thank you.
Have a great day. Thank you. Bye-bye. So hope everybody enjoyed that. We'll get the hopefully be able to get a PDF of the PowerPoint sometime in the next few days, which we can upload. And now it's over to you, Mohammed, to talk about what's been going on in the community and what's going to be going on in the community next week.
Sure. Thanks, Patrick, for that. And yeah, so regarding I'm very thankful to Akash. He was very busy in giving talks, and I requested him for a long time to come here and talk, and it was a very wonderful talk. The mathematics behind everything is mathematics, right? But you have to do not run away from the mathematics symbols that are there. You have to slowly, one step by step, learn it, and it takes time. To be honest, in data science and AI, coding is fast. You can learn coding fast. You can do other things fast, but the maths and stats take some time for us to comprehend and understand. So it's very great, and thank you. I think he's still there. He's on the call, but I think he has off his video because he has to go for another talk. Thank you. Yes, Umar is also leaving. Yes, Umar, regarding Umar's question about AI team, yes, it has to be there. So AI strategy has to be in place, and skill sets can come later. You need to first get a data strategy of what the company is going to do in the next 6 months, and according to that, hire people. So that it does not come hand on hand that you need to have 5 data scientists to 5 data engineers. First, you need to have the data strategy in place. What is your steps in the next 6 months? And according to that, hire. Started with a consultant, external consultant, try to build a project, and then try to hire parallelly internally. It's a long-term strategy to start AI and set up AI teams. So that's it. I wanted to just add a few points on that. Thank you. So now coming to our quick weekly update. So our group was quite active in the last week. Mainly, there were a few new things that were happening. There were a lot of discussion about Llama. So Llama, many people started using the Llama and discussing about it. I think Zach is not there in the call, or maybe I'm missing him out. Yes, so yeah, he's not here. So these are the things that were discussed. And also, if I see the summary, there were a lot of questions about data science roadmap, and someone was asking about contact for spiritual data chatbot, right? They wanted to create a spiritual data chatbot, and they were asking for some. Ashraf, you're talking something? You're asking something? Hello?
What is Llama?
Llama is a large language model by Facebook.
Okay.
So it is an open source model. So OpenAI GPT, what we are using, right? Mostly ChatGPT, open source model by OpenAI. We don't have the parameters. We don't know the parameters. But Llama is a large
visualization tool, like a visualization tool.
No, it's a large language model, like ChatGPT.
Okay.
Good. Thank you, Ashraf. Yes. So that was it about that. And the other things that were discussed about, many people are asking about roadmaps, and the answer is, as Akash also told, it is very personal. You need to understand what you want to do, right? What you want to do and why you want to do, and the path will always come on the way. How you traverse the path is the later step, right? What is your end objective? Why you want to do this, and where you want to go, and why you want to go is important. The how you will go is not that important. You will figure it out anyways. There are a lot of resources to do that, and there were a lot of discussions, and I recommend people to use this community opportunity to ask your questions, to discuss about the latest technologies, because so many things are happening in AI that it's very tough to keep a track of it. And this community, the conversations that we are having really helps us in that. And also, I try to invite guest speakers. Like today, Akash, he's a friend of mine, and I requested him to share his knowledge. He's very much into maths and statistics, and he thinks in that angle. So his knowledge that he shared was very, very powerful. He shared a complete subject, right? A complete subject in 1 hour. I know it was very quick, but at least you get an idea what all is happening. The 4 types of the models that are there for in the generative AI space, the encoders, the noise diffusion models, and all those things. Those are the base of generative AI, and at least you should read these things as he told. And also, one thing is, attention is all you need. Is a paper that has been released by Google about transformers. So that is also a very interesting paper that was giving you a base about all these concepts that is there about the large language model. So let me just quickly share my screen. Then please, you can also have any questions, use the chat to ask your questions. Me and Patrick will take your questions, and as well, let me know if you can see my screen. So is Praveen there on the call? I think Praveen and Savaria, just put a yes. Let me check. No, he's not there. Okay. Praveen, are you there? Just put a hi or something. I think he was initially there. Now he left. Cool. Okay, no problem. That is fine. So, okay. So, regarding the community updates, we can see my screen. We have basically 3 weekly events that we are planning to put every week. We are having this. So, the 2 are LinkedIn audio events. One is about the business use case of generative AI, how AI can be used for businesses, specifically the new generative AI space, wherein we are generating images, text, video, and whatever things that are there. It's a new field. Still, companies are figuring out how they can do it. And we are trying to explore this field. We are trying to do this LinkedIn audio event Thursday evening. All the details are there in the event page. Saturday, now we have actually shifted this to Sunday, because Saturday we are already having this talk. So we have shifted this to Sunday. Let me just put an update here. So we are doing this on Sunday, 12 p.m. This is also a LinkedIn audio event wherein we are going to have a career and AI and data science question. Many people have question mark about the AI and data science career, what to do, how to go ahead, what should I choose, what should I focus on. And this web audio event is a good way for me to share my knowledge, my experience, and people to ask their questions. And we have our Saturday 4 p.m. All the time that are mentioned are in Dubai, UAE time. The meetup for 1.5 hours, where we have a speaker who talks for around 20-30 minutes. Then we have an open discussion on the topics that are there and anything new that is happening. We have 2 monthly workshops. So that is there for August. We have done one workshop wherein I took a unicorn company data set and did an analysis. It was a 1-hour workshop wherein I just introduced how we can use Python and do a quick data analysis for a unicorn based company about what are the industries that are doing well, not well, what is the valuation, the total raised money, and all those stuff. And on 8th of August, it is going to be a 2 hours detailed outcome based workshop wherein I'm going to also introduce a real estate data from Dubai, how we can take that data and how we can do an analysis. So the data is a real data that is coming from the Dubai government website. We are going to use Python and code interpreter here because we are trying to do this project in 2 hours. It's a big project, but we are going to use the power of code interpreter. You don't need to buy the membership. You can follow along with me how I am doing it. I will share you the notebook, because the code that is going to be generated, I am going to put that code in my notebook, in my Python notebook, and I will share the final code and the final video to all our premium members that are there. So this is one very detailed project that we are going to do. And also later on, how the reciprocation will be there. Maybe we can do a follow-up session for the these type of data analysis projects wherein we do hands-on and get experience. And I would love everyone's feedback also in the call here about what all things to do. Why we started with Python data analysis? Because this was the most voted thing in our community when I was planning the workshop. So that's why we started with this, and we are planning to do a lot more workshops. But we will start with the basic workshops. We will try to get more buy-in and try to also invite guest speakers to do some workshops that is relevant to our community. And also we are planning, I and Patrick met yesterday also, we met. We are planning to do a physical meetup, and I will just take a poll. We are planning to on an end of August in Dubai, UAE, Emirates Tower, Coders HQ. There is a place that Coders HQ has offered a small, you can say, a auditorium type of location for us. So I will plan it on a weekday. On a weekend, I'll take a poll, because many people prefer on a weekday, because weekend they are little bit busy, or they have family time, or they don't want to travel. So I will take a poll. We will do it on a weekend or on an end of this month, wherein we'll have a 2 hours or 2 to 3 hours of talk. Maybe we can have 2 speakers or a workshop plus a speaker. We will plan it. We will take your inputs. Patrick and I will take your inputs. But we want to do at least monthly one physical event in Dubai, and also live stream it. Live stream that event on a Zoom call, or we will figure it out. We will keep you guys updated. That is our mission that is there. So regarding the challenges, we always push for challenges. And also for speakers, right? I always help or request people in our community also to talk. Would we be able to go along with the video? So would we, can you, Leo, repeat your question? Would we be able to go along with the video?
Yeah, you were talking about the 2-hour workshop, and if we're unable to make the workshop, would we be able to pick up the details, like to repeat the details on our own laptop? Is that, or
yeah, So Leo, so this will be recorded. So this is a part of our premium membership. So I will introduce. So we have if you have been part of this community, we have a premium community. So this all the recordings and everything that we do will be available for that community, and also this recording, the code and everything will be available for them. So the video will be there, the code will be there, so you can always follow up, and also you can ask questions in the premium community about what you're facing, and me or Patrick can even help you and guide you. So that is the mission about that, right? So we have a very big free community, but many of them are not, you can say they are just users of AI. They are not learners of AI. They're not. So what we are doing, we are creating a premium community that I've talked about, wherein
Is
we
this
have.
the Artificial Intelligence Guild?
Yes.
Oh, okay. I'll join now. Yeah, I can see you have a good 1 year thing. So I'll
Yes,
sign
so we
up.
have. So I'm going to talk about that as well later on. Yeah. So that is everything is there. So we are trying to people who want to learn AI, who want to take a step forward in this direction. We would recommend AI Guild is a good platform for them. People who just want to know what is happening in AI. All these events that you see in this are the first 5 events are free events that we do. Only the workshops, because it is very detailed, we need hand holding. We cannot open it up for everyone. So only people who are serious, for them we are trying to do this. So this is the part of that. And also the workshops that the challenges I keep doing it to promote people to get their ability to keep learning these skills. So I post the challenges. We have a LinkedIn page, group page as well, and also I request for speakers. I regularly, anyone of you who knows someone personally also who wants to speak, you can introduce them to us, me or Patrick, and we can talk to them and invite them to give a talk here for half an hour or something. And now coming, if Praveen is not there in the call, because he was earlier there in the call, I think he has gone to some other event. I think he has won this week's challenge, and I would congratulate Praveen here, and I will reach out to you personally to hand over. So Praveen, so now what we are doing is, we and Patrick decided we are going to give a quarterly membership for Guild to the winners of the weekly challenges. And also just before the call, I was talking to Pact. The Pact is one of the ebook subscribers, one of the publishers of books. They are if you can see my screen. I will just share you the details maybe in the group, but if you guys are here, so they have agreed to sponsor. They were earlier sponsoring us with a free book for the winners. So I think we had a winner from this group, Azam, in the earlier hackathon. So again, they are ready to sponsor, but this time I have requested for them to give an ebook, 2 ebooks, and the ebook is going to be about generative AI and LLM. And it is going to be 2 ebooks, because physical book, the problem is it takes time to deliver, and there are some courier charges. Sometimes it gets stuck in the border, because we are a global community. So you publishers are in the US and sending books and all. So ebook is a good option. We have agreed for 2 ebooks, and I'm going to announce it. This is a book on generative AI, and this thing, if I can maybe share this. We have 2 minutes, but I will share with the community. It is very interesting book, and I will put let me just show it also to you guys. I know it is. I wanted to put it here. It just got confirmed before the call, so I could not get time. So this is the book. Yeah, this is the book. Modern AI and yes. So this is a very interesting book, and I have actually read this ebook. So they had given me this ebook to review, and I am still reading it. Till now, it is an amazing book, Modern Generative AI with ChatGPT and OpenAI model. So they have talked details about what even Akash has talked about, and I'm reading it, and I'll give a review maybe later on. But I'm going to do a challenge. So we have 2 ebooks. So I'm going to do 2 challenges this week, this month, for these 2 ebook challenges that are there, and you can try to participate and try to get this book. Now coming to our Guild community, right? So all the courses, and courses that were there in my academy. So I run an academy. I am putting all the courses for the Guild community, right? You can see in my screen, generative AI, prompt engineering, Excel, SQL, Python. I just added advanced Python also last week. I'm transferring 1 by 1 video to this platform. It is taking time, and the plan is within the next 6 months, everything, all the 40 courses that I have in my academy will be shifted to this platform. And right now we have an quick, and we have all the recordings that are happening which are shared here. All the workshops that are happening are shared here. All the data sets, all the generative AI resources that are reviewed by someone in the community. We're not just sharing random things. The things that we have used or we have created and we have reviewed, because we want to cut the noise in this community. We want to only share things that are owned by me or reviewed by me. That is there, or Patrick, or any expert who is contributor in the community. So everything we are trying to put it out in this premium community, right? All the academy, you just need one access. You just need one access. It's just like a coffee a month. At the price of a coffee a month, like you will get access to everything, all the workshops, all the recordings. We are going to do live programs very soon once we have some numbers, where we have some live Python class. I used to do it earlier, but now I'm going to start it where I'm going to get 50% off directly for the live people who are interested in live programs, and also one-on-one mentorships. And so we are going to increase the price from Monday to $97 a year, and 1 month will be $12. Introductory offer, only 2 more days are there. Whoever are interested, this nas.io/AI guild, we'll put it on the chat. Do join if to take this opportunity. And if we are trying to cut the noise, put everything in one place, and it is taking a lot of time and energy. And one personal request is, please show up to these meetups. This is the starting point to be a part of this community, because if people are interested, we will get more speakers, more quality speakers. As you can see, it is a motivation for speakers to talk if there is a crowd. I know it is very, very valuable information that they are sharing. They're taking out their time from their busy schedule and speaking to us. So, and we also take a lot of time and do a lot of reminders. So I just request you guys to show up. We are having Saturday 4 p.m. Dubai time and India time 5:30 these calls regularly. Put it in your calendar, do register, do confirm your this thing, because I need to tell to the speaker how many people have registered. Someone was asking, right, why do you ask registration every day? Because I need to prepare for the logistics. I need to tell the speakers. If we have 5 people, 10 people coming in, then speakers will not be motivated to come and talk, right? So I hope you guys understand this. Patrick, over to you. Thank you. I took a lot of time, and I hope we can take any of your questions.
Yeah, just another one. On the 19th of August, we provisionally have a gentleman called Javier Idiami coming to talk to us about large language models. He's a international speaker on the subject, and he's done talks at Stanford. He's a Silicon Valley startup. He's based in Spain now. He has one of the biggest selling, if not the biggest selling, large language model and generative AI courses on Udemy. And when he does a presentation, we'll get to understand a bit more about him. But he's a very creative guy as well. He's an award-winning film director as well. He's won film awards in Dubai, France, other places around the world as well. So, and he makes films about large language models and all sorts of things, generative AI and all sorts of stuff. So he's looking forward to that one too. So he will be talking about large language models generally. So looking forward to that. Yeah, and just to repeat what Mohammed said, we need you to come to these meetings in order to attract the quality of the people that you want to hear about. Yeah, it's a virtuous circle. The more people that watch this thing, the more important speakers that we can attract. You know, it's our dream. Maybe one day we can have a physical event in Dubai over a couple of days where 1,000 people turn up and we have the best top speakers from around the world. And maybe that's a year away, or 2 years away, 3 years away. But we would love to do that. You know, so be the premier event for data science and AI in the region. So to do that, we have to grow this, but it has to be value to you as well. It's got to be valuable to you, and to make it valuable to you, we need your help. So please help us to help grow it. It's everybody can pitch in. You're all very intelligent and smart people, so please come up with some ideas for presentations yourself. Even if if you're just a beginner in the subject, you're just studying neural nets or something, then come and present about the basics of neural nets and how it works. Doesn't matter if you're not an expert. Just share your knowledge and we can all help each other. Like today's lecture went completely over my head. I did study this stuff 30 years ago, but I forgot most of it. I'd have to go back to probability and statistics classes. But I used to love, genetic algorithms, neural nets. Basically, when I did it 30 years ago, we were just starting and getting into that. But I've completely forgotten most of it now. Now I'm interested in how to use it to do interesting things. So, today was probably the most technical session we've ever had. I hope we want to mix it up. We want to have deep tech sessions like that. We want to have fun, creative things like that, which I believe Javier will provide, and business applications of as well. Content. I'm probably going to be doing a presentation myself over the next few weeks about more stuff about content creation. For those of you who like building content, there's some tools I've been doing a lot of research on investigating. So I'm going to show you and demonstrate some of those tools. Anyway, thank you all very much for coming as always. We really appreciate it. And we look forward to seeing you at the same time next week. Take care, everybody.
Thank you. Have a great evening. Bye-bye.
Take care. Bye.
Mohammed, can I ask you a quick question?
Yeah, you can ask.
So I've joined the guild, so I just want to make sure that do you have an email that goes out for when you have your events? So I'm not going to miss anything. I want to try to get to as many things as possible.
Yes. So the event.
Well, what's the best place? Is it just in the WhatsApp group? Is the best place to learn?
Yeah, I mean, we repeat a lot of the events in the WhatsApp group, and when you register, you will get reminders. Like
Okay,
the day
great.
before, like an hour before it starts.
Okay, great.
So there's an automated system built in.
Perfect. Thank you so much. Thanks
You're
a
very
lot.
welcome. Very welcome.
Have a
Thank
great
you.
weekend.
And you.
Same to you guys. Take care. Bye bye.